This is problem 1 of standard 8GB8, where we're going to apply the Pythagorean theorem to find the distance between 2 points in a coordinate system. So let's look at this particular problem. The coordinate plane below shows the locations of segment Q and R. Q is at point -4, 3. R is at 8, -6. What is the unit distance between the two endpoints of the segment? In other words, what is the distance between Q and R? What is the length of this line segment? We can find that if we use Pythagorean theorem, if we draw a right triangle. So let's draw a right triangle on this one. Okay. With our pen, we're going to draw a right triangle. From the Q, we're going to go down along this line till we get to where the R is going to be, right here. Okay, I've drawn that side. Now let's draw along this line here till we get the R. See how we've drawn a right triangle? And our right angle is right there. The key is we're needing to find the length of this segment. Now we know when we have a right triangle, if you've got a right triangle and you're trying to use Pythagorean theorem, a squared plus b squared is equal to c squared. Our c is always across from the right angle. It's the hypotenuse. It is the longest side. So we're going to go ahead and label this c. It doesn't matter here which one is a or b. On the legs, we're just going to name one a and one b. But c has to be across from the right angle. It's the longest side. How do we find the lengths of a and b? We count the number of units. We count the units from Q down to the segment here where we cut across to R. This line segment is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. So it's 9 units long. From 3 to -6, it's 9 units long. See, all of these are in units of 1, so we can just count. Let's count this one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. From -4 to 8, 12 units long. Okay, in place of the A, we're going to substitute 9 because this segment was 9 units long. In place of the B, we're going to substitute 12 because this segment was 12 units long. 9 squared plus 12 squared is equal to c squared. Okay, 9 squared. We know 9 squared is 81. We should know that without a calculator. We know 12 squared is 144. We should know that without a calculator. That's equal to c squared. Now, with your calculator, add 81 and 144. 81 plus 144, and you get 225. I'm going to substitute 225 in place of this 81 plus 144, and that's going to be equal to c squared. I'm pulling this down. Now, 225 is equal to c squared, but I'm not looking for c squared. I'm looking for c. The opposite of c squared is to take the square root of c squared. What I do to one side of the equal sign, I have to do to the other. C squared, if I take the square root of c squared, it is c. The square root of 225. In your calculator, if you've got a TI 30x2s, you would go second function, square root, 225, and say equals, and you've got 15. So c is equal to 15. The length of this side is 15. Let's see if that makes sense. We know the hypotenuse is always the longest side. This side was 9, this side's 12, this side is 15. That would make sense. What's the unit distance between the two endpoints of the segment? The distance, the length of that line segment then is 15. We got that using Pythagorean theorem and drawing our right triangle.